Good morning students, we are entering to the 8th lecture on this course, that is data analytics with Python. Today the topic is probability distributions. So what we are going to cover today, it is a very interesting topic. We are going to see some empirical distribution and its properties, then discrete distribution. In the discrete distribution we are going to see binomial, Poisson, hypergeometric distributions. In the continuous distribution we are going to see the uniform, exponential, normal distributions. First of all, what is distribution? What is the purpose of studying the distribution? The distributions describes the shape of a batch of numbers, that is the meaning of distribution. Okay. Suppose the different set of number is there, you want to show what shape it follows, whether it is a bell shaped we can call it as a normal distribution. If it is forming a rectangular shape we can call it as a uniform distributions, like this that describes the shape of a batch of numbers. The characteristics of a distribution can sometimes be defined as a small number of numerical descriptors called parameters. So each distribution's characteristics is expressed with the help of its parameters. Parameter is nothing but, for example, normal distribution, it has two parameters, one is mean and variance. With the help of that you can draw the distribution, that is a parameter. Why distribution? Can serve as a basis for standardized comparison of empirical distributions, because if you want to compare with phenomena with a very standard distributions, we can come to know that what distribution it follows. Then it will help you to estimate the confidence intervals for inferential statistics, that we will see what is the meaning of confidence interval in coming classes. Then form a basis for more advanced statistical methods. For example, fit between observed distribution and certain theoretical distribution is an assumption of many statistical procedures. Suppose why we have to study the distributions? Suppose if you are doing a simulation, for example, the arrival pattern follow Poisson distributions. Suppose set of data you have collected, if you prove that it is arrival follow Poisson distribution, already there is a mean and variance and other population parameters already defined it. If you have a natural phenomena, if you are able to compare with the standard distributions, there are well defined distribution parameter is there, that parameter you can use as it is, that is the purpose of studying the distribution. Then we will go for what is a random variable. If you want to construct a distribution, it is the relation between x and corresponding probability, x comma p of x. So here the x is nothing but random variable. A variable which contains the outcome of a chance experiment is random variable. It is a kind of a quantifying the outcome. Suppose if you toss a coin, for x equal to 1 is getting head, 0 getting tails. So 1 is nothing but here random variable. So the x is the random variable that can take the value of 1 and 0. If the x value is 1 it is a head, if x value is 0 it is a tail. A variable that can take on different values in the population according to some random mechanism. So the value of 1 and 0 it follows certain mechanism. Random variable can be a discrete, it may be a distinct values countable. For example, year is a discrete random variable. For example, mass it is a continuous random variable. Then probability distributions. The probability distribution function or probability density function PDF of a random variable x means the values taken by the random variable and their associated probabilities. If you make a relation between x and corresponding probabilities p of x or f of x, that if you plot that point that will form a distributions. So PDF of a discrete random variable also known as PMF, probability mass function. Example, let the random variable x be the number of heads obtained in a two tosses of a coin. There are two possibility when you toss two times, two tosses. First toss you may get head, second toss you may get head, then h tail, tail head, tail tail. So these are the sample space. Probability density function of a discrete random variable, suppose we are tossing a coin two times, the probability of getting 0 head is 1 by 4, the probability of getting 1 head is 1 by 2, the probability of getting 2 head is 1 by 4, sum should be 1. See in the x axis the random variable is taken 0, in y axis corresponding probability is marked. So in x axis random variable, in y axis corresponding probability, this is called as the distributions. Now, probability distribution for a random variable x, we will do a small numerical problem. A probability distribution for a discrete random variable x is given. So, x is given, corresponding probability distribution is given. So, this is an empirical distribution. Suppose if you want to know what is the probability of x less than or equal to 0. So, what you have to do, wherever random variable x is 0 and less than or equal to 0, you have to add that. For example, 0.20 plus 0.17 plus 0.15 plus 0.13, you will get 0.65. Suppose if you want to know the probability for the random variable minus 3 to 1, minus 3 less than or equal to x less than or equal to 1. So, you have to add minus 3 to 1, 0.15 plus 0.17 plus 0.20 plus 0.15. When you add it, you will get 0.67. How to plot a discrete distributions? So, number of crises for example is taken, the probability of happening that crisis is also given. For example, the probability of getting 0 crisis is 0.37, for 1 crisis 0.31 and so on. So, in x axis you mark the random variable, in y axis you plot the probability, right. When it is 0.37, when it is 1, this one. You see that these are discrete, these points cannot be connected. In x axis, this random variable has to come to the x axis, this probability has to go to y axis, for example 0.37 this one. Here what will happen, you cannot connect this line because it is a discrete, because you may have when x equal to 1, when x equal to 2, when x equal to 1.5 there is no value. If it is a discrete distribution, you cannot connect these points, that is why it is called discrete distributions. Okay. The requirement for a discrete probability density function, so probabilities are between 0 and 1 inclusively, the total of all probabilities equal to 1 and sum of probability, we have seen that already, it is 1. Next the term, we will see cumulative distribution function. The cumulative distribution function of a random variable x defined as capital F of x is a graph associating all possible values are in the range of possible values with p of x less than or equal to small x. Cumulative probability distribution function is just adding the probabilities. The CDF always lies between 0 to 1, that is 0 less than or equal to capital F of x should be less than or equal to 1, where capital F of x is CDF, cumulative density function. Then there is a very important property, is the expected value of x. X be a discrete random variable with a set of possible values of d and Pm of s p of x, the expected value or mean value of x is denoted as, generally expected value of x or mu of x is sigma of x multiplied by p of x. So, sigma of x and multiplied by p of x is your expected value of x. What is the meaning of this mean and variance of a discrete random variable is, look at this, there are picture A and picture B, the left side the mean is same for both the distribution, but look at the variance. The left side figure it shows there are a lot of variance, the right hand figure it is less variance. The probability distribution can be viewed as a loading with the mean equal to the balance point. So, mean is nothing but it is like kind of a balance point over which the distribution lies. Part A and part B illustrate equal means, but part A illustrates a larger variance. See the second case, mean and variance of a discrete random variable. The probability distribution illustrated in parts A and B differ, even though they have equal means and equal variances, the shape of the distribution is differs. Now, we will see how to find out an expected value. Use the data below to find out the expected number of credit cards that a customer to a retail outlet will possess. So, x is a random variable, that is how many number of credit cards a customer is having. The p of x equal to capital X is corresponding probability. So, 0 equal to 0, p of x is 0.08. That means probability of a person having 0 credit card is 8%. Probability of person to have for example 6 credit card is 1%. So, how to find out the expected value? You have to multiply it by x and corresponding probability you have to sum it. So, 0 into 0.08 plus 1 into 0.28 plus 2 into 0.38 and so on plus 6 into 0.01, 1.97. You can make it around 2. That means the customers, they can have an average 2 credit cards. Suppose any customer if you take randomly, average that customer can have 2 credit cards. Here is an example of meaning of this, what is mean. Now, we will see how to find out the variance and standard deviation of an empirical distribution. Previously we have seen mean x into p, sigma of x into p of x. Now we will see how to find out the variance of a empirical distribution. Let x have the PM of p of x and the expected value is mu. We know already the mean of a empirical distribution. Now we have to find out the variance of the empirical distribution. Then the variance of x denoted as v of x or sigma square x or sigma square. The variance of x is equal to sigma of x minus mu whole square into p of x. Variance can be written as e of x minus mu whole square. The standard deviation is just square root of this. We will see one example. A quiz scores for a particular student are given below 20, 25 and so on. Find the variance and standard deviation. So, before knowing the standard deviation, first you have to find out the mean, because the mean is required. So, the mean, if you add and divided by corresponding elements, number of elements, you will get 21. Okay. For example, first we will construct a frequency distribution. You see 12 is repeated by 1 time, 18 is repeated by 2 times, 20 is repeated by 4 times, 25 for example 25 is repeated by 3 times. Then we have to find the probability. The probability is nothing but the relative frequency. As I told you, one definition of probability is relative frequency. So, what is the cumulative frequency here? First you have to find a total frequency 1 plus 2 3, 3 plus 4 is 7, 8, 10, 13, that is the cumulative frequency. So, the probability here we are obtaining by using the concept of relative frequency. So, the relative frequencies we are adding all the frequency, that is the total. So, 1 divided by corresponding sum of all frequencies, 2 divided by sum of frequencies. Now, the mu, we can find out mu in another way also. We know that already we have done this relative frequency is sigma of f into m divided by sigma of f. How to find out the mean? Sigma of expected value x into p of x, 12 into 0.08 plus 18 into 0.15 plus 20 into 0.31 plus 22 into 0.08, sigma of x into p of x, that is 21. One way you can add all the values you can divide by number of elements. Otherwise, from this empirical distribution, what is x is given, x is 12, 18, 12, probability is given. So, if you want to know the mean, x into p of x. Now, we are going to find out the variance. So, p1 here is 0.08, x1 is 12 minus mu whole square plus p2 is 0.15, x2 is 18 minus mu whole square and so on. When you add it, you will get the variance, and the when you take square root of, you will get the, yeah, you see that. And going back 0.08, so 12 minus 21 whole square plus 0.15, 18 minus 21 whole square plus 0.31, 20 minus 21 whole square. When you simplify, the variance is 13.25, standard deviation is 3.64. So, what we have done seen this problem, the data is given, first we have constructed a empirical distributions, then we have used the formula of mean and variance to find out the mean and variance. The another shortcut formula to find the variance is nothing but the E of x minus mu whole square, for example, already we have seen E of x minus mu whole square. When you square it and simplify it, you will get this formula. So, variance of x equal to sigma square, sigma of x square minus p of x minus mu square, this can be written as E of x square minus E of x whole square. Just you have to expand it, you will get this answer. So, let us find out the mean of a discrete distribution. The formula for finding the mean, mu equal to expected value of x, that is x into p of x. So, x is given, p of x is given, multiply x into p of x. After doing that, when you sum, the sum is 1. So, the mean of this empirical distribution is 1. Let us find out the variance and standard deviation of this empirical distribution, that is a discrete distribution. So, sigma square we know x minus mu whole square into p of x. So, x is given, p of x is given. first to find out x minus mu, then x minus mu whole square, then multiply this x minus mu square by p of x and sum it, you are getting 1.2. So, the variance is 1.2, when you take square root, the standard deviation is 1.10. Okay. Suppose then another distribution, say x is given, p of x is given, x into p of x. So, when you plot it, the mean, you see that the mean need not be exactly 1 or 2 or 3, mean value may in between 1 and 2. So, mean value need not be discrete, only the random variable is discrete here. Some of the very important properties of expected values. Suppose expected value of a constant is constant only. When you want to multiply two random variable e of x plus y, we can write e of x plus e of y. E of x given y is not division, it is a conditional, it is a kind of a conditional probability. So, e of x given y need not be, will not be equal to e of x divided by e of y. And same thing, e of x y is not equal to e of x multiplied by e of y unless they are independent. If they are independent, we can write e of x y equal to e of x and e of y, otherwise we cannot return. So, if a random variable come along with a constant, that constant can be removed out of this expected value. For example, e of a x, the a can be brought left side. So, a e of x, here where the a is the constant. So, you see that it is in format e of a x plus b, that a can be brought left side. So, e of x, then when you expected value of b constant is the constant itself, it will become a e of x plus b, where a and b are constant. Then properties of variance. So, variance of a constant is 0. If x and y are two independent random variable, then variance of x plus y equal to variance of x plus variance of y. Variance of x minus y equal to variance of x plus variance of y. You should be very careful here. Suppose there are two groups there, group 1 and group 2. If you want to know the difference in the variance, you have to add their variance. If b a constant, then variance of b plus x, because variance of b will become 0, it will become only variance of x. If a is a constant, then variance of a x is, because variance is the square term, when you bring left side of the bracket, you would write a square and variance of x. There are proof is there for this. If a and b are constant, then variance of ax plus b equal to a square variance x, then variance of b will become 0, then answer is a square variance of x. If x and y are two independent random variable and a and b are constant, then variance of ax plus by equal to variance a square variance x plus b square variance y. Then covariance. For two discrete random variable x and y, e of x equal to mu x and e of y equal to mu y, then covariance between x and y is defined as covariance of x comma x y equal to, can be written as sigma x y, e of x minus mu x and e of y minus mu y. When you simplify, you will get e of x y minus mu x multiplied by mu y. That is a covariance. In general, the covariance between two random variable can be positive or negative. If random variable move in the same direction, then the covariance will be positive. If they move in the opposite direction, the covariance will be negative. Properties of covariance. If x and y are independent random variable, their covariance is 0, since e of x y equal to e of x dy. If it is independent covariance, there will not be any variance. Covariance of x is variance of x, similarly covariance of y is simply variance of y. Then correlation coefficient. The covariance tells the sign, but not the magnitude about how strongly the variables are positively or negatively related. The correlation coefficient provides such measures of how strongly the variables are related to each other. So, the covariance is only giving the direction, not the magnitude, but the correlation is giving the magnitude. For two random variable x and y, e of x equal to mu of x and e of y equal to mu y, the correlation coefficient is defined as covariance of x y divided by sigma x sigma y. Dear students, now we are going to some special distributions. We will study some special distribution in discrete category and continuous category. In the discrete, we will study about the binomial distribution and Poisson distribution and hypergeometric distribution. In a continuous category, we are going to study uniform, exponential and normal. In this class, I will explain the theory and corresponding its parameters. After the end of this class, we will use Python to find out various parameters, various mean and variance of your distributions and corresponding probabilities in the practical class. First one is the binomial distribution. Let us consider an example to explain the concept of binomial distribution. Let us consider the purchase decision of your next 3 customers who enter a store. There are 3 customers going to enter their store. On the basis of past experience, the store manager estimates that the probability that any one customer will make a purchase is 0.30. What is the probability that 2 of the next 3 customers will make a purchase? Now look at this, the tree diagram. The first customer, there is a 2 possibility. S is the purchase, F is the no purchase, X is the number of customers making purchase. So we will see that is the end here. Now what is happening? The first customer, he can purchase or not purchase. Second customer, different possibilities. Third customer, different possibilities. Now we look at the experimental outcome. This possibility, look at this possibility, success, success, success. Look at this possibility, success, success, failures. Look at this possibility, success, failure, success. Then success, failure, 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 success, success, failure, success, failure, 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 success, failure, failure, failure. So we have written all possibilities. Now the question is, out of 3 customers, what is the probability that 2 customers will make a purchase? What is the meaning SS is, all 3 customers have purchased. So value of X equal to 3, random variable. Second case, 2 customers have purchased, third customer did not buy. So X is 2, because here the X is taken the number of customers making purchase. The first possibility X equal to 3, the second possibility is 2, third possibility 2, the fourth possibility is 1, 2, 1, 1, 0. Now the question is, what is the probability that 2 out of 3 customers will make a purchase? You see that there is a possibility. The first customer, it is a possibility SSF, SFS, FSS. What is the probability of success is P and 1 minus P. We know P is 0.3, so 0.3 square 0.7, we are getting 0.063. For second category also, we are getting P, first is success P, failure 1 minus P, again success is P. So P square multiplied by 1 minus P, so 0.3 square 0.7, 0.063. Then third possibility, failure 1 minus P, success PP. So P square 1 minus P, 0.063, 0.063, 0.063, right. Now here actually here the possibility is 3C2, because the question is asked, out of 3 customers, what is the probability that 2 customer will buy? So it is a 3C2. The value of 3C2 is 3, that is why 1, 2, there are 3 possibilities. When you go back, how many 3 is there? 1, 2, 3 possibilities. That is the meaning of our 3C2. Okay. Now we will find out the probability. If X equal to 0, that means nobody is buying. Students, we have studied so far variance, covariance, correlation coefficient. Just I will make a relation. For example, we know the variance formula, variance equal to sigma of x minus x bar whole square. So variance is for one variable. Suppose if you want to know 2 variable, if you want to know for 2 variable, this variance will be called as covariance. So covariance is sigma of x minus x bar into y minus y bar, variance divided by n minus 1 is there, n minus 1. So sigma of x minus x bar into y minus y bar, here also 1 minus 1, variance, covariance. Next one, Okay, correlation coefficient is covariance comma x comma y divided by standard deviation of x and standard deviation of y. Now, you see that this is variance, this is a covariance correlation coefficient. So, for correlation coefficient, when you divide covariance divided by corresponding standard deviation, you will get correlation coefficient. Next, we will say m, that is called slope of a regression, slope of a regression equation. So, that is nothing but your covariance of x comma y divided by variance of x. The first one is variance, covariance, correlation coefficient and slope of regression equation. You see that all are having some relationship. For the variance is only for one variable. What is the meaning of variance? How each value is away from its mean. That deviation, square of the deviation, then sum of the deviation, then the mean value of that sum of the deviation will give you the variance. For covariance, there are two variables there. How each variable is moving away from its own mean. So, sigma of x minus x bar multiplied by y minus y bar divided by n minus 1. If you want to know correlation coefficient, that covariance is divided by corresponding its standard deviation, you will get correlation coefficient. If you want to know slope of a regression equation, if you divide covariance of x comma y divided by corresponding variance of x, you will get a m, that is nothing but slope of regression equation. Dear students, so far we have seen what is the need for studying the distribution, then we have seen how to construct a discrete probability distribution. After constructing, how to find out the mean and variance of a discrete distribution. Then we have seen the properties of expected value. Next, we have seen the properties of the variance. Then we have seen how this mean, variance, covariance are interrelated. The next class will continue some discrete distributions and some continuous distribution in detail. Thank you.